So we notice, back up, undo. So we notice as our x gets closer and closer to 5 on the left and the right, notice these decimals, they get closer and closer to the same decimal, 0.0278, 0.0278, 02, because of rounding, 0.278. So as we get closer and closer to the pointed question from the left and the right, it approaches the same thing. So the left-hand limit equals the right-hand limit, so then we say that the limit exists. Okay. Let's see what else we got going on. So use the results to estimate the limit. So if I had to estimate, if I had to do an approximation, I would say that it's approximately negative 0.0278. That's what I would say is the approximation. Now, that's one technique using the f of b minus f of a, the slope between 2 points. Now, another way we can look at it, instead of saying a and b, we could so now say we had our original point when x is 5, and then we want to just do some change, just some distance off to the side. So another x value, just some change. So then as that change goes to 0, as that change gets smaller and smaller and smaller, the second point is going to get closer and closer to the original, okay? So then if we evaluate the slope between that change and the original, as that change goes to 0, then the approximation that we get of the slope of the secant line becomes a better and better approximation for the slope of the tangent line at the point, okay? So that technique comes out in the following way. We'll do something like we're going to take the limit as our change, we're calling it h, as the change goes to 0, of f of x plus h minus f of x over h, okay? So in the first one, the h is there, and the second one, the h is 0. So it's the same. It's the same as what you see here. It's just that your b is h. Is that right? Sorry. Your b is x, and your a. Sorry. Your b is x plus h, and your a, the h goes to 0, so you're left with x. So the b is it's the same. All you have to do is say that b is x plus your change, and your a is going to be x. So now as that change goes to 0, b approaches a, and you get this formula, okay? So then, now, if I was going to do this with ours is f of x equals 1 over x plus 1, right? Then what I would do, and this is just an alternative. You can do this, and I'm going to put a big or. This is just... Usually we add this in, and your teacher should introduce this other technique. I'm not too clear on the names, but this is my understanding of what's going on. Now, if I'm getting something wrong, please leave it in the comments, and we can edit it and change and fix and all this kind of stuff. But I'm putting this out there because I want to make sure I'm on the same page as others. So, all right. So if I plug in x plus h, if I plug this in, so then I'm going to have the limit as h approaches 0. Now, when I plug in x plus h, I'm going to have x plus h plus 1 minus 1 over x plus 1 all over h, right? So it's the same. It's just that the first part, wherever there's an x, I plug in x plus h. Now let's simplify this. This is going to be equal to the limit as h approaches 0. Now, if we're going to add these, we need a common denominator. So we're going to have x plus h plus 1, x plus 1. So that the left one is missing the x plus 1, so we include it. The right one is mixing the x plus h plus 1, but we got to distribute the negative. So we have a negative x minus h minus 1. That's just adding and subtracting fractions and getting a common denominator. And then all over h, right? Notice that this cancels that, this cancels that. If we divide by h, we multiply by the reciprocal. So this is going to be the same as the limit as h goes to 0. Is going to be h times x plus h plus 1 times x plus 1 all under a negative h. Okay? So then notice these h's can cancel, and then we'll get the limit as h goes to 0. You got x plus h plus 1, x plus 1 all under negative 1. Okay? So now, if you take the limit as h goes to 0, you're going to have x plus 1 quantity squared under -1. And so if we're doing the limit as x goes to 5, then that's going to be a -1 over 5 plus 1 quantity squared. It's going to be a -1 over 36. So when x is 5, then the slope of the tangent line at that point approaches the -1 over 36, which is approximately the -0.0278 that we got. Or let's do this. What this bar above the number means is that that's repeating. And actually, to be a little bit more precise, we can just do it like that. Okay? So as x approaches 5, I get this result. Now, let's see how to do this in the calculator. I think we did all this. Yeah, I think we did all this. So we were able to fill in the table. Okay. Let's make sure to answer all the pieces. So it says round to 4 decimal places. We filled in the table. I'll show you how to do that. And then it says use the result to estimate the limit. Use a graphing utility to graph the function to confirm your result. Okay, so let's use a graphing utility to confirm. Now, if I go to my y equals, this is my original function, right? What I'm going to do is suppress the second one, and then this third one, I want the slope. So what we're saying that this is, we're saying that this -1 over 36, and this answer that we got, what we're saying is that this is the slope of the tangent line at that point. So if this is the slope of the tangent line, what we can do is graph that tangent line with this slope, and it should touch our graph at a point, okay? So if the slope is a -1 over 36, and then we said when x was 5, our y was, I think, a +1 over 6. So then let's find the equation of the line with this slope going through that point, all right? So then we can just say, point slope form is going to be y minus y1 equals m times x minus x1, right? This is our x1, this is our y1, okay? So then we're going to say y minus y1 is the 1/6. The slope is a -1 over 36. X minus x1 is 5, right? So then if we solve for y, I'm going to just add the 1/6 to both sides. So then y is going to be a -1 over 36 times this x minus 5 plus 1/6, all right? So then if we simplify, I'm going to distribute like this. So then I get my y equals -1/36 times x, and then it's going to be plus 5 over 36. And then if I get a common denominator, that's a 6 over 36. So then we'll get y equals a -1/36 x plus 11/36. So we're saying that to show that this is the appropriate slope, we're going to graph this line in conjunction with our original. So then here I'm going to say parentheses -1 over 36 close parentheses x plus open parentheses 11 over 36 close parentheses. Okay, so now that y3 is going to graph showing us that that's the proper slope, and then y1 is our original. Now we need an appropriate viewing window. All right, we need an appropriate window. So x, I'll let x go from like -1 until maybe 7. So let's go to the window. We'll go from -1 up to 7, so that way we can see the origin. We can go in steps of let's go in steps of 1/2. Okay. We can go in steps of 1. Let's just simplify it. We'll go in steps of 1. Now the min, the y value there is a +1/6. So I want to go down to, I'm going to go down to a -0.5. What's that? What was that decimal? Yeah, that's a really, and it's not that high. I'm going to go up to 0.5. So I'm going down to -1/2 up to 1/2. This is like 0.1. So I'm going to go in steps of, if I did steps of 0.1, I'll have 5 tick marks. So if I divide that by 2, I think if I go in 0.05, I'm going to go in steps of 0.05 so that I can have a few more tick marks and I can get a better sense of what's going on. Hopefully, let's cross our fingers and see what happens. Okay? Let's cross our fingers, and basically we should get something that looks like, kind of like this. It's just the blue might not have that much of a curve, but it should be a straight line touching the graph at one point. Cross our fingers. So we got the curve. Oh, bam. It touched it at one point. Ah, that's so much fun. See, this is what I mean. Oh my God. They call that boy the human calculator, the GOAT, the greatest of all time. You can't stop him. To make the calculators, they picked apart his brain, and that's how they got the calculator. Look at that. Calculators is a reflection of us. Okay, so this technology, it comes from our mind. You know, it's like we forgot who we are. We forgot about our power. We forgot that we know how to do this, and we're afraid to embrace it. But look, I literally did it by hand on a quick sketch on the left, and then I did it in calculator, and it did exactly the same thing. Okay, and then we could plot the point to show all that, but that's beside the point. You see that. Let me go to stat plot. So if I go to stat plot, I need to go to edit that. Where am I stat? If I go to stat, I'm going to go to edit. I want to plot this point. So when x is 5, y is 1 by 6. So when x is 5, my y is a positive 1 over 6. I'm going to go to my stat plot. I'm going to turn it on. I just want the dots and list 1 and list 2. Yeah, so now when I go to the graph, just be careful using stat plot, because if you forget to turn it off, your graph won't graph. Like if you change something, it'll still be there. So when you're done, it's a good idea to turn it back off. Go up to stat plot and turn it off. Okay, so you can see the point. Just to kind of play around a little bit more. Instead, I'm going to change the cursor to this plus and see if that looks a little better. But you see the plus, it goes right through it, and then the line crosses at that point. All right, you can't tell me that's not fun. See, that's the fun part about math. When you go through all of that and you get it right, it's worth it. But trust me, it came from being wrong a lot. You eventually, the beautiful thing is, like, again, this is why I go by the name Beautiful Mind. And again, if you know anything about the movie, it is what it is. But, it still is really beautiful. Like, there's a saying that goes, a million no's and one yes is still a yes. See what I'm saying? So if I've gotten this stuff wrong a million times, it doesn't matter. Once I get that yes and I know how to master it, it doesn't matter. From then on, it's a yes. A million no's and one yes is still a yes. So that's enough of that. That's enough of being on the soapbox. Hopefully you found some fun. Hopefully I kind of sparked some interest, and we answered the question. Let me make sure I answered the question completely. So it says complete the table. We rounded to 4 decimals. We did that. We got an approximation. It all came together. We saw it in the graphing utility, and we saw it by hand. Okay, with all of this. Okay. So with that,